In this video, we're going to finish the topic roots of polynomials. So in the previous video in this topic, I went through objective 1 and objective 2. So now I'm going to talk through objective 3, which is the factor theorem. So more specifically, at the end of this objective, you should be able to use synthetic division to evaluate functions and to prove factors exist for specific functions. Alright, so the factor theorem goes hand in hand with the remainder theorem, and it states similar things. And the factor theorem states specifically that if there is no remainder, so it's still dealing with the remainder, if there is no remainder after dividing out the function by k, and notice the positioning of k, the polynomial x minus k is a factor. So, more straightforward, if you divide out the factor from the polynomial and you get a remainder of 0, then you know that it is a factor indeed. Same as the remainder theorem. If you divide out the value of x and you get a remainder of 0, then you know that x is a root. So, let me show you what I mean by this. And there's only one difference. It says given x minus 2, so it's given us a factor instead of a, if you remember from the examples before, we were given actual values at x equals -3 or x equals something. So now they're giving us a factor. And so that should clue me that in order to use synthetic division, I can't use the factored form. I have to use the root form. So I'm still going to use synthetic division, but my first step looks a little bit different. I have to change factor to root form. And so I have a factor of x minus 2. I can solve it by setting it equal to 0, so plus 2, and now I have x equals positive 2. So I'm going to evaluate with synthetic division at x equals 2. So now the process is the same, but that was my first thought as I approached this, and I read the question given x minus 2 is a factor of the function, factor the entire function completely. I know that if I have to use synthetic division, I have to use the root form right here. So that is my first step. And so that's what you should be thinking as you do this. If a problem asks you to find is this a factor of the polynomial, in order to use synthetic division, I have to change it to root form. All right, step 1, done. Step 2, synthetically divide the root out to check for remainder. So this is review from the previous objectives at this point. I draw my synthetic division box. And now, instead of, if you notice in the factor, it's x minus 2, but again, I'm going to use the root form. So I put the root of 2 here, or the value of x. Okay. And then I fill in my top part here with the coefficients that are in front of the variables. The first one is 1. It's not written, but I know that it's 1. And then the next one is a positive 6. And please keep in mind, what are the powers doing? And it's x cubed, and it goes to x squared, so there's no skipping there, so I don't need a space holder of 0 to take the place of a power that's missing. And then from there, 6x squared, it goes down to the linear x, so again, it goes from 2 to the power of 1, so I don't have to have a space holder. And then finally, negative 30. So at this point, I'm done filling out my synthetic division box. Hopefully you remember that a way to check yourself at this point is the highest power of the polynomial is x cubed, so I should have 4 terms on the top of my synthetic box, and I do in this case. I have 1, 2, 3, 4, so I did that right. I know I can move ahead with the math now. First step, drop down the first term, 1. I multiply to the outside, add to the inside. So 2 times 1, the answer goes right below the next number of 6. So 2 times 1 is 2. I add now, 6 plus 2 is 8. Then 2 times 8 is 16. Add in the middle, negative 1 plus 16 is 15. And finally, 2 times 15 is 30. At this point, because it lines up directly underneath my last number in the synthetic division box, I draw my remainder box. And so, after I do this math, negative 30 plus 30, I get a remainder of 0. And so because I get a remainder of 0, according to the factor theorem, if there is no remainder or a remainder of 0 after dividing out the factor, then I know that dividing out the function by k itself, which we found was here, then I know that it is indeed a factor. So I'm going to put r equals 0. Therefore, I know that x minus 2 is a factor. Now, something cool about these theorems, they kind of go hand in hand. Because x minus 2 is a factor, and there was a due to the fact of a remainder of 0, I know that its solution, x equals 2, is a root. They go hand in hand that way. So if it's a factor, it's always going to be a root. So please keep that in mind, because eventually we're going to move into solving polynomials and finding all of the roots, so we can know that to be true. If we divide out a factor and its remainder of 0, then I know that its root is also a root of the given polynomial as well. So at this point, that should have been review. Now it's moving into a little bit new learning, because the rest of the directions say factor the entire function completely after you factored out the given factor. So at this point then, I'm going to go back to my numbers down here. These numbers come into play and will continue to come into play for the rest of the module. I have to add variables to them. So if you look at the beginning, the highest power was 3. All right, but when you divide something out, you lose a power by 1. It's taking it away, it's factoring it out. So instead of x cubed, now the highest power that goes with my first number is x squared. And then I just go down the line. After x squared is the linear x to the 1, so I add x to the 1 to my 8. And then after x to the 1 is just a number. And so if I did this math right, usually it works out pretty clean like that, to where it goes x squared, x1, or x cubed, x squared, x1, and then the number. It usually goes in order like it should. And so I'm going to rewrite, because I just did step 2. I synthetically divided out the root, check for remainder. And now, step 3, if no remainder, rewrite the new polynomial and factor completely. So I'm going to rewrite the new polynomial, which is x squared. And I put plus 8x because this 8 is positive. And then I put plus 15 because this 15 is positive. And it's telling me then to factor it completely. And you should notice, something should jump out at you at this point, that this right here is a quadratic trinomial. And we know how to factor quadratic trinomials. We've been working with it since Module 2. You use the MacAb T-chart. So I'm going to use that to factor the rest out completely. So for Mac, I put 15. Ab, I put 8. 15, I have to find factors. 15 divided by 1 is 15. But 1 plus 15 does not equal 8. 15 divided by 2 doesn't work. It's not a whole number for my answer. So that doesn't work. And then try 3 after 2. 15 divided by 3 is 5. So 3 plus 5 is indeed 8. So I have found my remaining factors. So I'm about to factor it completely, my final step. So I'm going to write it in factored form to factor it completely. So I have y equals x minus 2, my original factor that I did indeed discover was a factor because of the remainder of 0. Then my new factors from here, x plus 3 because the 3 is positive, and x plus 5 because the 5 is positive. So I have done everything. So if you can get to this point with these problems, you're doing great, okay? In fact, a lot of the practice work, I'm just going to have you get to this part, where you factor out the given root or factor to see if it has a remainder, and then you rewrite what is left. So that's where I want you to get. If you can write it in factored form, awesome. And now, if you can even take it a step further, especially if it looks as clean as this, because eventually we're going to get into solving, you should hopefully be able to recognize that the solutions of this are pretty straightforward. X equals 2 for this first factor, x equals -3, and x equals -5. And to check my work, remember the fundamental theorem of algebra states the highest power equals the number of roots. The highest power of my function was x cubed, x to the 3rd, and I do indeed have 3 roots. So I did everything correct. All right? But again, the goal for this objective is to at least get synthetically dividing out and then rewriting and then writing in factored form to here. So it's time for you to try your own problem. All right? So your problem is a little bit different than the one I just did, only because there's two factors that they want you to test to see if they are indeed factors. And so what that means is you're going to do synthetic division twice, okay? So you're going to take this step by step. I want you to try it first to just do the first round of synthetic division. And if you notice, there's two factors, x minus 2 and x plus 3. And again, you have to do the root form of those factors. And so go ahead and synthetically divide out the first factor, x minus 2, all right? See what kind of remainder you get, and then once you have the numbers written down here, pause the video and check your work with mine, okay? Because then I want to show you the next step of how you synthetically divide twice, all right? So go ahead and pause the video, try dividing out x minus 2 on your own, and then play the video again. I'm sorry, play the video so you can check your work with mine, and then continue on from there. At this point, you should have paused the video and tried factoring out the first solution, x equals 2, out of the polynomial. So this is my work. Check your work with mine. Hopefully you've gotten the same numbers that I did down here again. That's how you check your work. Make sure that up here looks the same, that the math is all good, and that you got a remainder of 0. You should have gotten a remainder of 0. Now, all that's different, and when you synthetically divide twice, you just draw another synthetic division box. And it's convenient because you already have your new numbers written up top. And you just divide out the next root, which x plus 3. So in this case, it would be x equals negative 3. So you divide out negative 3, drop down to 2, and you multiply to the outside, add to the inside. So now pause the video again and go ahead and try to get to the final step, which is rewriting up here the new polynomial, and then go ahead and factor it, if you can, to get to something that looks like this. So go ahead and try to finalize the process, and then after you pause the video, you can work through it and then check your work with mine. So go ahead and pause the video and try that. Alright, so if you did this correctly, you should have gotten to here, at least. And then if you rewrote it like you should, remember, you lose a power every time you synthetically divide. So we started with the power of 4. We did synthetic division 1 time, then 2 times. So my final polynomial would have the highest power of 4 minus 2 is 2. So I rewrite it as 2x squared, and then the next one after x squared is just an x, and then finally just the constant. And then to rewrite the polynomial function, it becomes 2x squared plus 5x plus 3. And if you notice, you can't factor with MacAb because the leading coefficient is greater than 1. So if you wanted to, you can then, and this is technically the next module, so this wasn't an expectation of mine, but if I just wanted to preview it for you, you can use the quadratic formula to solve the quadratic equation and get the final 2 roots. So at the beginning, there was a power of 4, so I had 4 roots that I was looking for, and I have x equals 2 right here, x equals negative 3, x equals 5/4, and negative 3/2. But that is just a preview. Again, if you can get to right here, you are doing great. So make sure your work got to at least right there. And if it didn't, please raise your hand so I can come check it.